In this video, we are going to talk about structures of functional group. We are going to see how OH group is bonding with the carbon and what is the structure of this functional group. In the case of methanol, that is CH3OH, we can say that sp3 hybridized carbon atom is forming bond with sp3 hybridized orbital of oxygen atom. sp3 hybridized orbital of carbon atom will make a bond with sp3 hybridized orbital of oxygen atom in OH group. We are able to see two lone pair of electron on oxygen atom, and the bond angle between COH is 108.9 degree, little bit less than the tetrahedral bond angle, and the bond length between carbon and oxygen is 142 picometer. Bond length of oxygen and hydrogen is 96 picometer. So we can consider this bond angle and bond length. Here in methanol, the bond between carbon and oxygen is sigma bond, because sp3 hybridized orbital of carbon is bonding with sp3 hybridized orbital of oxygen atom. So the bond is sigma bond, and the angle between COH is 108.9 degree, that is quite less than the tetrahedral bond angle 109 degree 28 minutes. And it is due to the repulsion between unshared electron pairs of oxygen. Oxygen is having two lone pair and the bond angle is little bit less due to the unshared electron pair on oxygen atom. The COH bond is sigma. sp3 hybridized orbital of carbon will bond with sp3 hybridized orbital of oxygen, and they will overlap each other to form a bond between CH3 and OH. Now we can move to phenol. When we are moving to phenol, we are able to see the bond angle is almost near to tetrahedral bond angle, that is 109 degree, and the bond length is 136 picometer. When we are comparing the bond length between this oxygen with this carbon, it is less than in the case of methanol. Do you know why? The reason is that this carbon oxygen bond is having a partial double bond character, because in benzene ring it is having conjugate double bond. Therefore, due to the presence of lone pair on this oxygen atom, this carbon oxygen bond is having partial double bond character. That is the reason why the bond length is less than the bond length in methanol. Here it is 142 picometer, it is 136 picometer only. Now in either, you are able to see the bond angle between COC is 111.7 degree, and the bond length between carbon and oxygen is 141 picometer. The bond length is almost same like our methanol, but bond angle is higher than the tetrahedral bond angle. The structure is almost like tetrahedral, but bond angle is more than tetrahedral bond angle. The reason is that the repulsive interaction between two bulky R groups. These R groups are bulky one, so there will be a repulsive interaction between two bulky R groups. CO bond length is 141, which is almost same as an alcohol. In this case, we can say 2 bond pair and 2 lone pair is the oxygen is having 2 lone pair of electron and oxygen is having 2 bond pair of electron, which is almost arranged tetrahedrally, but the bond angle is slightly greater. So in these 3 cases, methanol bond angle is 108.9 degree, slightly less than the tetrahedral bond angle. In phenol it is 109 degree and in ether it is 111.7 degree.